My name is Josh Prager. I'm a principal consultant here at SpecterOps. I've been with the company for, this is actually my 6th year with SpecterOps. Prior to that, I was in the US Navy. Started as a radio man, worked my way up to the Navy Red team. Did that for a little bit. And then I did a completely different shift and went into threat hunting with in-game. Did that for a couple years and then jumped over to SpecterOps. Okay. All right, so what we're going to be talking about is Configuration Manager, or SCCM. You'll hear me talk about those names kind of like interchangeably quite a bit. Just a real quick primer, all right? SCCM enables site-wide configuration and control of different endpoints. Essentially, all the different clients within each site can be controlled by the management points, the distribution points, and overall the site hierarchy. So if you want to deploy a package, you want to deploy an application, deploy a particular script, update a patch, even deploy an entire operating system to a client within Configuration Manager, you can do that all within the SCCM infrastructure. Okay. All right, so there's a bunch of different attack paths that the SpecterOps team has come up with over the last couple of years, where we can attack credentials located within distribution points, such as like Pixie creds. We can try to identify SCCM infrastructure with different reconnaissance methods. Our overall goal is to do what's called site takeover. We're essentially compromising the entire domain, or at least as much of the domain that's included within that site hierarchy as possible. But it's kind of hard to track all of this. So a couple years ago, we came up with the Misconfiguration Manager project. Okay. We try to kind of roll it into a well-known, relatable taxonomy. So we have recon, cred, elevate, takeover, execution. And then we also have some defensive techniques in there as well. So we have prevent, detect, and we also have canary. Recon is about, as you would think, identifying SCCM infrastructure. Credentials is anywhere we can find legitimate or elevated credentials in the environment related to SCCM infrastructure. Elevation, execution, these are ways that we can typically privilege escalate and then execute code on a remote system. And then takeover is when we're usually taking over like the entire site hierarchy. That's our goal in this case. When we take over the site hierarchy, we can essentially act as administrators over whatever is within that site. Most clients lump their entire environment into one giant site hierarchy. That's not the way that we advise folks to do things. And when that's done that way, we can take over their tier 0 endpoints all through SCCM. Okay. So originally, Misconfiguration Manager was written by Dwayne Michael, Chris Thompson, Garrett Foster. When they came out with the project, Dwayne reached out to me and said, "Hey, we're coming out with this project. We're going to release and publish a lot of our SCCM tradecraft that we've been using on pen test and red team assessments. We also want to have a defensive portion." And so Dwayne reached out to me and said, "Like, can you work on the detection portion?" And I was like, "Absolutely." So when I wrote detections for it, I came out with like 3 or 4 detections at the time. And then, doing a bunch of pen tests, doing a bunch of defensive engagements for clients focused on SCCM. I published a lot of the other detection techniques that I came up with through testing and validation. Okay, so that's essentially what we're going to be talking about today is detections for Configuration Manager that I've published through the Misconfiguration Manager project, the detect portion. But I'm also going to be talking about evasions for those detections as well, which is not published or released on that project. Okay. So kind of getting back to the Misconfiguration Manager project, Dwayne, Chris, and Garrett used kind of that like MITRE attack matrix look to define and organize these attack techniques. You might see some familiar ones in there where we have like privilege escalation, which is essentially relating to site takeover. If you look in there, you'll notice that a lot of these privilege escalation methods are related to relay. Okay. And relay, NTL and relay, coercion and relay is a very important part of these takeover attacks. Okay, so like, why does this matter to you? If you've never really looked into this before, if your environment uses Configuration Manager and you've never really been too concerned with adversaries using it, essentially Configuration Manager can basically lead to domain compromise if configured incorrectly. And I mean like complete domain compromise. It's very difficult to eradicate in this case if an adversary was to legitimately abuse Configuration Manager against you. I remember my first introduction with Configuration Manager back when I was a sysadmin, working in help desk and things like that with support. I remember my NetOps like enterprise manager telling me like, hey, here's the credentials for a lot of our configuration manager accounts. These need to be locked up and like never ever be released. We need to be really careful with how we use these. Configuration manager is a very, very powerful tool. I remember having to apply STIGs when I was in the military to configuration manager. And I remember thinking, I'm like, man, we're like, this seems like a really powerful tool to be able to just basically execute things as local admin on any client that is allocated under this site. That seems really dangerous, but that's the way it's done, right? So it's very, very powerful. Configuration Manager has the ability to push applications to clients, push scripts to clients, reconfigure the entire client, modify things at a local admin system level. You can deploy entire operating systems all within Configuration Manager. So it's a very, very, very powerful. When we teach our identity-driven offensive tradecraft course and we introduce SCCM to the class, the very first thing that Alad says is that SCCM, also known as our secondary command and control, because that's how we treat it. We can essentially take it over and then use it to push our beacons left and right wherever we want to go, okay? So let's talk a little bit about site takeover. So essentially site takeover allows us to compromise the entire site hierarchy. And the reason for that is because unless configured otherwise, in most default scenarios, one site database will replicate to all other site databases. Okay, so kind of starting from the beginning here, for SCCM, you have this front end portion that the administrators can see, and that typically is managing all the uploads of files, uploads of scripts, and things like that. That's where the users are interacting with, or the administrators are interacting with SCCM, and that's called the site server. And that site server is connected to a backend database, an MS SQL server, okay? That MS SQL server, it's just one of many MS SQL servers in a large hierarchy environment. If you modify that SQL server on one backend SCCM instance, it's going to replicate that to all the other databases as well. So we're going to talk about it here in a little bit, but if I add myself to what is essentially like the local admin group of SCCM in the database instance, I have added myself to all other secondary sites related to that hierarchy. And so compromising one portion of the hierarchy compromises the entire hierarchy. Okay, it's a very, very powerful technique. All the published known methods of site takeover leverage NTLM coercion and relay to some extent. Now, we might be relaying to different types of protocols, but we're essentially still trying to abuse the fact that the primary site server's machine account is essentially a local admin on the site database server itself. It's a sysadmin in the site database, and then it's also a local admin on every other client in that site system. So in other words, the machine account of the primary site server is typically system or local admin privileges on every other client within that site hierarchy, okay? And that's by default. That's just the way it is, okay? All right, so what we're gonna be talking about, we're gonna be talking about the detections that I proposed in Misconfiguration Manager that I published in there. If you have Configuration Manager in your environment and your defensive team is not designing custom detections to detect offensive tradecraft for SCCM, highly recommend you grab these slides and toss those their direction. If you are the defender and you are the detection engineer, definitely reach out to me, talk to me after this, and we can talk about what these look like in production, okay? But I'm going to talk about each one of these detections. I'm also going to discuss evasions for them as well. So if you are an offensive operator and you're like, I'm sitting in this detection presentation and I want to get something out of this, I'm going to give you evasions for a lot of these. When I say evasion, it doesn't always mean I'm going to completely bypass telemetry. I'm going to give you methods that will kind of like constrain the amount of telemetry that you're creating when you execute these actions, okay? All right, so let's talk about the first one that I came up with was Detect 4. So Detect 4 in the Misconfiguration Manager project tracks application deployments or application package deployments. Sharp SCCM, SCCM Hunter, even the Configuration Manager console, when it creates a package, an application for deployment and pushes it to a client workstation in that site, what essentially it's going to do is these four things. It's going to create a collection of devices. It's going to create an application or scope. It can also modify that collection of devices or modify the application or scope. It's going to create a deployment. You can't modify the deployment. You're going to create a brand new one, and then you're going to initiate that deployment. So Configuration Manager has this thing called this status message queue. And the Configuration Manager status message queue contains message IDs. Think of it as kind of like event IDs. Most clients that I've talked to are not ingesting these logs, okay? And these logs are essentially made up of two parts. There is the log that lives on the actual site server. It's called the smsprov.log. And the smsprov.log, if you just grab that raw log and looked at it, it'll say, SQL command for a user, initiated deployment of SQL command for deployment name. All right. And because what's happening here is the site server is communicating to the backend database server, and together those two entities are making one clean message ID that gets into the status message queue log. But if you take it apart, really it's the smsprov log that's grabbing what's being done, and it's relating it to the SQL database that's giving it the names, the properties of whatever is being tasked within this message. But essentially what we have here is we have 4 different message IDs that we can use. So we can kind of do a composite event where we aggregate these together and try to identify anomalous packages being deployed from a defensive standpoint. One of the interesting caveats about deploying this in production, when I've tested this in production in client sites, if I use Sharp SCCM or I use SCCM Hunter, any of like the real popular SCCM offensive tools, it'll show up as like SMS provider unknown. It'll show up as like SMS application unknown. And that's because it's not a default method of communicating with the SMS provider, the WMI provider, okay? So when you use Sharp SCCM, things like that, it's gonna show up as like application unknown as far as what's initiating this package deployment, okay? But we can use message ID 315, 3152, 3226, and then 40800 to identify where we're creating those collections, we're creating that application, we're creating that deployment, and then we're initiating the deployment. Okay, so what does this look like from an evasion perspective? So I actually ran into this during a recent penetration test where I was kind of like guiding the defenders against our own pen testers. And I told them, hey, look for these artifacts, look for these message IDs. And this particular client actually happened to be ingesting the status message queue logs from Configuration Manager. So it was great. So they were looking for this, and I knew that our pen test team had, initiated something through SCCM. And so I expected to see these event IDs, and I didn't. And so I dug into why not. So SCCM Hunter has a script module where if you've been able to execute code on the site server, you can load this script module and you can actually tell it to execute scripts instead of push applications to different clients. And that script module will generate different message IDs than an application deployment. A script deployment does different message IDs than an application deployment. So there's 2 of them that are related to script execution. And when it doesn't matter if you do like a command line script or if you do a PowerShell script, I'm going to show you in a second what it looks like. It's always going to be executed by PowerShell, okay? But what's going to happen is there's going to be a message ID for 52500, which is a script created. And there's also going to be message ID 52501 for script executed, okay? So you're kind of limiting the amount of telemetry you're making. Instead of 4 different event IDs here, now you're only making 2. Okay, but here's where it becomes the more preferred method of execution. Okay, this might be kind of hard to see from down there. I'm going to use I don't think I have a way to like zoom in. I'm going to do my best. So it's kind of hard to see from y'all. So you got to kind of press the I believe button and then go validate it later. But essentially, every time SCCM executes a script, the way it's going to do it is it's going to do it through this ccmexec.exe, and then ccmexec.exe is going to have a child process of PowerShell. And PowerShell is going to execute that script. Okay, cool. You're executing PowerShell, right? Like you're an offensive operator, PowerShell's dead, don't touch it, right? It's a little bit different when it comes to SCCM. When it comes to SCCM, everything that is executed through PowerShell, so every script that's executed is going to be ran through this invoke command script block, and then it's going to come from SMS underscore CCM, the script store, and then every command that you're giving it to execute as a script is essentially going to come through as this random GUID name .ps1, okay? I've never seen a client not filter this out because this is happening all the time natively in environments. In fact, most clients will just not ingest any PowerShell script block logging or process execution where the name CCM or SMS or anything related to SCCM is even contained, because it's like trying to find a needle in a haystack. These events are just happening all the time. Every time you do login scripts for your users, every time you're pushing patches, every time you're updating some kind of software on their client machine, this is the way that it's done. It absolutely blends into the environment to the best of its ability, okay? But it does have some unique status message queue logs in there. Like I said, the system is going to show up as unknown machine, and then the component, that's where it's going to be like unknown application if you do this with like SCCM Hunter or Sharp SCCM. If you want to be even more evasive, there's nothing, if you've been able to take over the configuration manager site, like done a site takeover, there's nothing stopping you from just downloading the configuration manager console to your machine. And if you execute and deploy scripts through the configuration manager console on your attacker controlled machine, at that point, it's going to be, system is going to be whatever that system you did that from. And then the component is going to literally say configuration manager console. It'll completely blend in, okay? Okay, so moving on, I talked a little bit about how the database will replicate in a site hierarchy, right? So there's kind of two important pieces to that. When we're talking about SCCM, remember I said there's a front-end site server, and then there's a back-end MSSQL server. And these two work together to basically track and push patches all throughout your environment. That's like the 10,000-foot view, too long didn't read version of that, okay? On the site server, on the front-end portion of SCCM, there is this local security group called SMS admins. When you add a user to SMS admins, it automatically gets added to this RBAC admins table in the SQL database server that serves as the backend for that SCCM site server, okay? There's kind of two methods here, right? One, we could compromise the site server and we could add a local admin to that SMS admins local security group on the front end site server. The other way we could do this is we could compromise the database server and we could insert a user into the RBAC admins table, which would essentially give us the same like level of write privilege on that SMS WMI provider for SCCM, okay? All right, so let's talk about detections and evasions for this. So a detection, right? SMS admins is a security group on that site server. So there is an event ID 4732 where a new member was added to the group. And if you want to audit someone just directly inserting a user into the RBAC admins table of the backend database server, for that, you're gonna have to think outside the box. So what you can do is you can do custom SQL audits, where you're auditing for that RBAC admins and any sort of insert or the RBAC extended permissions tables. Look for those tables, audit those tables. When you set up this custom SQL audit, you can tell it to go to any log provider that you want it to. In the example that I used, I had it go to the application log. It's going to generate a custom event ID 33025. That 33025, this is kind of truncated to show you as much as I can all in one. It gives a lot of details. It tells you what user did the submission. It shows you what user did the insert into RBAC admins. It tells you what user was inserted into RBAC admins. We have clients that have pushed this into production. It does work and it works very well, especially because of the fact that typically most environments are not just daily changing whoever their SCCM admins are, right? It's like the same 15 people for the last 10 years. So anytime there is a update or change to any of these groups, it's a big deal. Everybody knows about it in most cases. So that's just kind of showing a data model of what those detection techniques look like, okay? All right, so let's talk about evasions. So most organizations I've seen, they won't always put just a particular user into the SMS admins group. SMS admins is a local security group, but it is tied into Active Directory in a way where most clients I've seen will do a Active Directory security group. And so there's not, Josh Prager as a user inside of SMS admins. It's typically, I'll see like SCCM admins as a AD security group within SMS admins. So the evasion in this case is kind of like trading one event ID for the other. If you can compromise Active Directory in a way, you could add a user to that SCCM admins group, which would be nested within that local security group. It's not really an evasion in this case because you're still making the same amount of telemetry. You're just making a different form of telemetry, really. Okay. Okay, so shifting gears again. So one of the other detections that I proposed was for credential access through Pixie Creds. So pre-boot execution environment, if you've ever been in a situation where you've worked help desk or system support, you might be familiar with Pixie, where you just plug in 50 workstations into a lab environment or wherever environment, and you're like, all right, use Pixie, and it just auto grabs the operating system, all the current configurations, patches, the whole gold image is all just loaded and ready to go all through Pixie, okay? The typical operational flow for offensive operators and the way that they identify credentials within pre-boot execution environment variables is what they'll do is they'll connect to a distribution point, okay? And there's a couple different ways you can connect to it, but the most common way is just through like an SMB name pipe. They'll go after this the share that's called REM-inst or remote install. Remote install is a part of the Windows deployment service, and it contains a bunch of these like Pixie variable files. These Pixie variable files are located in this folder instead of that REM-inst share called SMS temp. And then a lot of these offensive tools like Pixie Thief, ePixie Thief, things like that, SCCM Hunter, they'll essentially connect to the distribution point, identify if REM-inst exists, then go into that SMS temp folder and just spider all those .var files and look for credentials within those .var files, okay? From a blue team perspective, we can detect the connections made to the distribution point. We can detect the connection or search for that REM-inst share path. We have event ID 5145, which is a detailed file share event. If you're a defender and your organization ingests 5140, but they don't ingest 5145, highly recommend you make that switch over to event ID 5145. The detailed file share event will not only show someone connecting to the REM-inst share path, it'll actually show what objects within that share path they're connecting to. That's where it's more powerful. And that's not just for SCCM, that's for like all things file share events. Additionally, you can use event ID 5145 to identify folks connecting to anomalous name pipes or certain name pipes, right? So we can identify adversaries connecting to that REM-inst share path and then connecting to that SMS temp folder and then seeing them spider through those .var files in there, okay? I also have event ID 4663 in here, so that's a SACL, a system access control list. That's custom auditing for a Windows object. You'd have to set that up beforehand. So if you have distribution points in your environment and you are using Pixie in your environment, highly recommend you set up SACLs on that SMS temp folder, baseline normal activity, what's communicating with it, and then alert upon any deviation, okay? All right, so how can we evade this? So there's kind of two methods of detecting this, right? One of them is looking for those remote connections, looking for REM-inst share. And then the other one would be actually connecting to objects or enumerating through objects within that REM-inst share, okay? So most detections that are focused on things like LDAP are looking for where a large number of requests within LDAP are made over a short period of time. So if I was ingesting event ID 1644, which is the LDAP efficiency query log, if I was auditing LDAP queries and I saw someone trying to query remote install, if I use Pixie in my environment, that probably wouldn't stand out, but I have been in environments where Pixie's been deprecated for like a decade. It does stand out that someone is trying to query remote install because it doesn't exist, right? Some alternatives, right? Instead of just straight up going after remote install to see if it even exists, first we can do some port scanning. So those ports I have listed up there are ports specific to Pixie. We can also do a remote registry query where we're looking for that HKLM software Microsoft SMS distribution point or DP in there. And then we're looking for the is Pixie responder enabled or Pixie installed registry setting. You're looking for either one of those. Depending on your Windows deployment service configuration, you might have one but not the other. You might have all three. You might have that very last one. It just kind of depends on your configuration. So you just look for all three and see which one appears. If any of them appear, that means you have Pixie going. And then if there is a SMS pixie.log on that distribution point, that means you're also running, or at least at one point ran Pixie services, okay? All right, almost done. So when getting into remote and local enumeration, so a big piece of SCCM site takeover is it's pretty easy to identify the site server. It's a little bit harder to identify the backend database server, and I need both in most situations to complete a site takeover attack, okay? So a lot of times what we have to do is we have to do remote enumeration, and if we can't get anything with remote enumeration, we might have to switch over to doing local enumeration. If you didn't know it, if you are using SCCM in your environment and your devices are being controlled by an SCCM site server, every one of those client devices has a folder called C Windows CCM, okay? And within C Windows CCM is a whole bunch of log files that contain a lot of details about your particular site configuration. So the adversary doesn't always have to go and enumerate remote devices to identify configuration manager infrastructure. A lot of times they can just stay on the seated access workstation or the initial access box. And if that is controlled by SCCM, they can enumerate most of those details right there locally, okay? Okay, so for a remote detection, right? We have sysmon event ID 3 for network connections being made to that distribution point. We can also look for event ID 5145, that detailed file share event, where there's a connection made to the WinReg name pipe. That's showing someone doing like remote registry queries. Alternatively, you can use sysmon event ID 18 as well. For a process accessing a remote registry key, if we set up a SACL on that registry key itself, knowing that an adversary might try to enumerate that from a distribution point, we'll get an event ID 4663 showing us the process, the host, and even the user that tried to enumerate that distribution point. And then we can also look for LDAP queries, right? A lot of offensive tradecraft or offensive tooling will use LDAP queries to enumerate SCCM infrastructure, but the way that they're doing it is, as far as LDAP is considered, as far as Microsoft is considered, it's looked at as inefficient because they're doing things like star SCCM star or star MECM star. These are considered inefficient LDAP queries. And so that event ID 1644 is the LDAP efficiency diagnostic log, and it'll look for anytime an inefficient query is ran. And that's typically a very easy way to identify things like Bloodhound, things like SCCM enumeration, any kind of infrastructure enumeration or remote identity manager object enumeration. You can usually grab it with LDAP. All right, so how do we avoid this from an evasion perspective? So from an offensive perspective, when you're searching for SCCM infrastructure, try to constrain those LDAP queries as much as possible. Avoid mass enumeration, okay? Some detections that we've seen at other client sites are things like we're essentially the defenders are cataloging how many LDAP queries a user is making in a time bucket period, say in an hour period or in a 12-hour period. And if the user makes, above a certain threshold for that particular number of LDAP queries, generate an alert for that user because it's like anomalous, right? So that's one way you can do it. What you can do instead is you can manually query those distribution points, or like I said at kind of the beginning of talking about this, we can enumerate a lot of those configuration manager infrastructure settings locally through that C Windows CCM and all those logs in there. Okay. There are ways to detect these queries within the logs itself. We can set a SACL. Defenders can set a SACL on that C Windows CCM folder path, and then baseline that activity. Typically, a normal domain user would never need to be cracking open that file or any of those log files that are within that folder. Okay. All right, and then this is just a bunch of resources and everything, and that's it. Questions?
You said earlier that you can execute scripts from the admin endpoint, and that it was just a random GUID that you saw in your logging. But is there a way to retrieve those scripts based on that GUID so you can review them?
Yeah, so there is a script store within there. I think the slide actually shows it if you can squint really hard, because I don't really have a way to zoom in. So the location of those scripts are C program files, SMS, CCM/script store. So those scripts are going to be contained in there. It essentially just kind of gets uploaded, like CCM exec.exe, in this case almost acts like a beacon for SCCM. And so that CCM exec.exe is going to upload that script to that script store based on whatever that GUID name is. And then it's going to use CCM exec to execute the child process PowerShell, and then PowerShell is going to execute that script. Unfortunately, this is like the default way that SCCM pushes out scripts. I tried to kind of figure out a way to differentiate between our offensive script execution and legitimate SCCM script execution in an environment of about 75,000 hosts. And there was like 6,000 script execution events happening in a minute. So it was like almost inhumanly possible to be like, that's my bad script, which is why I wrote it down as an evasion technique essentially. Whereas the application deployment was a bit more anomalous. For application deployments, there's typically a standard naming convention that the company uses. The applications are typically either sourced locally or sourced on a file share or something like that. So if there's a lot more steps to do something different and stand out as an anomaly. Whereas script execution is literally just like, here's your script, execute. When I did the last pen test that we did, the domain controller was controlled by the configuration manager primary site server. So we executed a script on the domain controller to add one of our seated access users as a local admin on the domain controller who could then run, secrets dump or whatever they wanted to do. So I know like my slides are kind of written in a way where it's like, okay, I talked to you really quick and you just take them home and then use them later. I do that on purpose because I really can't stand it when I look at slides after someone gave a talk and I'm like, I don't know what the hell they were talking about. So I try to make my slides as a very take-homeable thing. So if you have a defensive team or whatever and you just want to give them these slides and they can work on it or whatever, that's kind of how I write my slides. I don't know when they'll release our slides for SOCON, but they typically release them within a couple of weeks. So they'll do kind of a big announcement of saying like, hey, we've released all the slides for SOCON. So definitely they'll put them on like a GitHub and you can just download them from there. Okay. If anyone has any questions, feel free to reach out to me on LinkedIn or Twitter or whatever, and I'll respond back. All right. Thanks, y'all.